Assalamu alaikum. Let's start our fourth lecture. In the previous lecture, we have developed the basics of the mathematical models, on the basis of which we developed some mathematical models, or you can say the equations of the process. Let's do here the first example. Consider the tank. This is the tank, and it is the heating system installed in it. This is the heater. The steam is entering from this side with a flow rate of Fs and having a temperature Ts, and leaving from this side. This tank is filled with liquid and a specific height is being maintained in this. A variable flow rate Fi and having a specific temperature Ti of the liquid is entering into the system and leaving from the base of this tank with a flow rate F and temperature T. Let's suppose the cross-sectional area of this tank is A. This is its cross-sectional area, and the density of the liquid is constant, and also they have said that tank do not move and there is no momentum of the heater. It means momentum is negligible. So our purpose is to construct the flow diagram. We have constructed the flow diagram. We have constructed the tank, the inlet having a flow rate Fi and Ti, the outlet flow rate Tn, and a steam entering to the system, giving the heat Q to the system so that the liquid inside the tank can be heated with a specific temperature. Yes, the tank is thoroughly stirred, so the temperature inside of the temperature of the liquid inside this tank is same as that of the outside. Okay. So, constructing the flow diagram, part A, 1, we have done it. Second part. What are the relevant fundamental quantities that are being changed in this system? What are the relevant, on the basis of that relevant quantities, what are the relevant balances that will be related to this? Okay. Now, as we can say, as there is an inlet flow rate is variable, outlet flow rate is variable, so this height is changing. This height is representing its volume by a formula. Volume is equal to area into height of this liquid. So this volume is the liquid height because this height is of the liquid, and the volume is representing the mass. So the basic relevant fundamental quantity in this will be the mass, and the related to it is we will be applying a mass balance on it. The second thing that is changing is the accumulation of energy because of the input from this heater and the changing inlet temperature Ti. The outlet temperature and the inside of the system temperature is the same. So the second fundamental is the energy. So we will apply the energy balance. As this system is comprised of the same liquid of same density, so no need for component balance. No need for the component balance. Okay. Now identify the state variables. State variables are those that describes the ट्रांजिएंट वेरिएशन ऑफ द सिस्टम, जो टाइम के साथ चेंज हो रही है. सो इन दिस केस mass of the liquid inside the tank is changing. This means volume of the liquid inside the temperature is changing. This means the height of the liquid inside the system is changing. This height is the state variable. Now looking at the second fundamental quantities, as I have said that energy is changing, accumulating because of the heater. This means internal energy is changing because kinetic and potential energy is 0, and this internal energy is related to the total enthalpy, and this total enthalpy is then related to the temperature. So this derived temperature is basically your state variable. So we can say easily that height and temperature of the liquid in the tank is state variable. And any equations developed on the basis of the height and temperature will be the state equation. Now the fourth part is the mathematical model. Okay, we have to develop the mathematical model. Now let's again see the system. Here is the system. So the mass balance says the rate of accumulation of mass inside the system is equal to the mass flow rate in and the mass flow rate out. Okay. Here we have to mention here that this flow rate Fi F naught is actually the volumetric flow rate. This is the in and this is the volumetric flow rate out. So now it will be easy for us. So the basics equation जो आपको पेपर में given होगी, that will be the rate of change of mass inside this tank with respect to the time equal to the mass flow rate in minus mass flow rate out. Now we know that volumetric flow rate Fi and volumetric flow rate F naught is, so we can write it dm over dt is equal to mass flow rate in will be equal to the, as we have said previously said, density into any volumetric flow rate Q. Now in this case they have given us the volumetric flow rate Fi, so it will be rho Fi for in, rho Fi minus rho F out. So the mass can be represented in terms of height by a formula rho into volume, and then volume is equal to area into the height. So putting that in the above equation, we have d rho ah over dt is equal to rho Fi minus rho F out. Now in this case our volumetric flow rate out is equal to F, and also in the differential density and area is constant, क्योंकि ना density liquid की change हो रही है ना tank का area change हो सकता है. So these two can be come out of the derivative dH over dt is equal to rho Fi minus rho F. Now from left side and right side you can say the density is constant, so it can be, we can divide whole equation by density. So it will be A dH over dt is equal to Fi minus F. Now this equation is the basic model equation that is representing the mass accumulation, and the state variable in this is height of the liquid. Now if the input Fi is changed, increase, what will happen to the height? The height will also increase. If it decrease, then height will also decrease. In case of outlet flow rate, if F is increased, the height will decrease, means it has an inverse effect. And if F is decreased, then height is increase. Okay, we have developed the first mathematical model equation. Now comes to the second mathematical model equation. As we know that the general equation of energy we have developed is dE dt is equal to du over dt is equal to mass flow rate in into enthalpy in minus mass flow rate out into enthalpy out plus Q. That is the heat added by the heater into the system plus shaft work. Now in this, the shaft work is 0, plus minus, the minus will be neglected because the only heat is that is entering into the system, not the leaving. Negative shows the heat leaving. So in this, heater is adding into the. So for the liquid cases, especially for the liquids, change in internal energy is equal to the change in total enthalpy. So this enthalpy is then by definition is equal to total mass into specific heat into temperature of the system minus some reference temperature. So inserting this equation to the above equation, we have d m c p T minus T reference over dt is equal to mi hi minus m naught h naught plus q. Now as we know, mass flow rate in can be represented by its volumetric flow rate, because we have given in the equation the volumetric flow rate, so it will be m into fi. The volumetric flow rate out is equal to rho into f out. Also, so we can put specific enthalpy can be of the inlet will be Cp into Ti inlet temperature minus T reference, and the specific enthalpy of the out is equal to the Cp over T minus T reference. Why I have not added mass here? Because it is a specific enthalpy, not the total enthalpy of the entering and leaving masses. So putting all this equation in the previous equation, the overall we will have the d m Cp T minus T reference over dt is equal to rho fi Cp Ti minus T reference minus rho f Cp T minus T reference plus Q. Now this mass can be represented into its volume, rho into volume, and then rho into cross-sectional area into height. So we can write d rho a h Cp T minus T reference minus is equal to rho fi Cp Ti minus T reference minus rho f naught Cp T minus T reference plus Q. Now in this whole equation the constants are density and Cp and cross-sectional area. So we can put them out from the derivative. It will be rho A Cp d h t minus t reference over dt is equal to rho fi Cp ti minus t reference minus rho f naught Cp t minus t reference plus Q. Now let's suppose we have given the T reference temperature as 0 for simplicity. So it will be equal to the rho A Cp d over dt is equal to rho Fi Cp Ti minus rho F out Cp T plus Q. So you can divide the whole equation by rho. You will have